You're also trying to achieve new heights in your Python project in 2024, but feel like something is missing? I got something for you. Hi, welcome to another cool project that I did in the scope of the Massachusetts Institute of Technology's program for applied machine learning. This time, we're going to build a model to predict whether or not an employee is going to quit a company. So this is going to be really exciting, I think, for you as well. You can just imagine that we're here hired as a data scientist, and our task is to identify any patterns that we see of employees who leave the organization, and then we want to use this information to predict if an employee is at risk of attrition. So we're going to build a model. First of all, we're going to always start with importing our libraries. To do so, we're going to load the dataset. I use here Mount G Drive because I like to store my data in G Drive. So I just connect G Drive here to my Google Colab notebook, or in your case, maybe Jupyter notebook, doesn't matter. And then we're going to read the dataset. So I'm using the pd.readExcel function to read the dataset. And then I'm going to use df.head to get a quick overview of the data. I can see I have here information on the attrition, yes or no, age, daily rate, etc. We can check the info on the data using df.info, but more interesting is to check for the unique values. You can already see attrition here is only two values, so 1 or 0 has quit the company or has not quit the company. And then I would always start with dropping the columns that are not informative for the model. So here, the employee number is just a identifier. So that is nothing that we should use to predict in our model later on. Over 18 is also not really representative. What we have here, I think it was just like one value anyway, because you can't work when you're below 18. Standard hours, also not interesting, so we drop it. We create a set of numerical columns and categorical columns later on to be able to transpose our categorical columns for better model prediction. And then we're going to start with our exploratory data analysis. So here for the numerical columns, we're going to use the .describe function. We transpose it for better readability. We get the count, the mean, standard deviation, minimum, etc. for each of the columns. So you can see here that the daily rate of salary is quite has a high standard deviation. So varies quite a lot between like 102, I guess this is in standard in US dollars, and maximum of 1,499 for probably some employees that have been with the company a little bit longer. That's what you can see from here. And then we're gonna do a bit of a visualization. So for all the numerical columns that we've defined above, we're gonna plot a histogram and a specific figure size. And we can see here, probably as expected, age is quite normally distributed. You have monthly income, also as expected, has a really right tail distribution. This is more uniform, the daily rate. Yeah, and you have some other interesting insights here. For example, years in current role, also right tail employees tend to stay up to 3 to 4 years here, at least most of them. And then some only stay a little bit longer. Years since last promotion, it looks like a lot of employees get promoted within 1 or 2 years. And also interesting is that a lot of employees tend to stay apparently with their current manager. So it looks like they don't switch roles as often. Maybe also something that the company could look into. We have some observations here from that. So we see that the majority of employees are between 25 and 50 years old. Some of them work apparently not from home, so they need to go to the office. So you have here a right skewed distribution, distance from home. So there's a few that live further away, but most of them are close to the office. If we want to do a universe analysis also with the categorical variables, what we can do is we can always just use value counts for each and every column to understand what's the percentage distribution of each of the values. Obviously, we want to do that efficiently, so we use a loop and just say for e in the categorical columns, please print out the value counts of each and every column. You want to normalize it as well. And then we just use here the little stars in between for better readability. So attrition, you can say 83% here of the employees don't attract, and then 16% have been leaving the company. You have 70% of the employees that travel rarely, and only 18% that travel frequently. You see that most of the employees are in the research and development department, versus like human resources is below a percent, below 5%, sorry. Have some other insights here for the categorical values as well. Now, after our summary here, what we can do is to start with our bivariate and multivariate analysis. So we want to understand how the categorical and numerical variables relate to quitting the company or not quitting the company. So what we're doing here is for the categorical values first, for the employees that are not quitting the company, we want to understand how what their distribution is on different columns, such as like overtime, versus the employees that do quit the company. So we're just going to use like PD crosstab for that very nicely. Good visualization to understand the differences here in quitting versus non-quitting employees. So for example, what is cool or interesting to see is that, as already kind of seen from above, that those employees that have to travel frequently, they tend to quit. There, at least there's a correlation with a higher quitting rate. You have a similar pattern for some of the other values. For example, here, job satisfaction. So those that are not as satisfied, they quit much more than those that are happy. Something that the company could look into. Same as for work-life balance. Not very surprising. Those employees that don't have a lot of work-life balance quit the company much to higher degree than those that do have work-life balance. Also interesting, I think, is that job involvement really determines if an employee is going to quit the company or not, as well as like the job role. So you can see like the more stressful roles is like sales representative and human resource, laboratory technicians. Those are the ones where you have a higher quitting rate versus like the higher paid positions, where you usually have a little bit more freedom. Research director, etc., has a low attrition rate. After that, we want to understand also the relationship between attrition and numerical values. So what we use here is the group by function to group by attrition, and then get the mean for all the numerical columns. Once we have that, we can like understand, for example, here that those employees that are working from a further distance that need to get to the office, they have a higher attrition rate. So for example, the company could look into, hey, maybe we want to offer some remote options that might help with our retention. Some other observations that you can look into on your own. What we also want to do is we want to understand the relationship between different numerical values. So here I'm just using a heat map from Seaborn to plot the numerical columns. What we can see here is, remember, higher correlation is what we are looking into. So for example, here, years with current manager seems to be highly correlated with years in current role, which means that employees tend to stick with the current manager a lot, and then also apparently do not switch roles a lot. So I saw something that the company could potentially look into. After that, we can like just write a quick summary of our exploratory data analysis and go right into model building. How are we going to build the model? We prepare the data for modeling. We, as you always remember, we make a split for the train and the test data set. And then we're going to build a model on the training data set. We tune the model if we need to, and we test the data on the test set. So for the preparation, we need to create a list of columns, for which we need to create the dummy variables. This is all the categorical ones. So here I'm just making a list of these column values, and then I create dummy variables here. I'm just using the function here from Pandas, get dummies, pretty easy. What I'm doing here is basically making a dictionary for overtime and attrition, where I just replace the values yes or no with 1 or 0 to be able to model these values much more easily. Then we need to separate into independent and dependent variable. We want to predict the attrition rate, so that's going to be our y, our dependent value, and then x is going to be all the other values that we have in here. What we also need to do is we need to scale the data. As you've seen, it's not very evenly distributed, so we need to scale the data. We use the standard scaler here for the x values, so pretty easy from the scikit function. We can just use the fit transform, and then from pandas we just create a data frame for that. We split into training and testing data sets, usual split 70-30. Remember, for sampling, you can always use either randomization or you can stratify the data. Randomization here doesn't work so well. Why? Because it would mean that you would get a different, you would get a high class imbalance, and that's not what you want. You want to keep a good class balance to be able to make an observation then from your model later on. So here you keep the class balance of 83 that are not quitting the company and 17 that are quitting the company. And that's the same across the train and the test data set, whereas if you would use randomization, you would see that there is a change in the class balance. How are we going to evaluate our model? We can use a confusion matrix. That's always one of the best things to use. So quite nice to know what's the accuracy, the sensitivity, recall, etc. So we're just going to make a function so that we can later on use the function metric score for the actual values versus the predicted values from the model to understand how good our actual model then is. Since this is a classification problem, we're going to use logistic regression. Remember, logistic regression is one of the most common types models to be used for these classification problems. So predicting yes or no, that's a class. Not going to go into sigmoid function that much now, but you can just use here the function logistic regression. You're going to fit your model on the training data. So that's what you do here. And then you're going to just check the model performance. So this is basically nice. Python is doing the entire modeling for us. We just need to check the performance. We can see here that we have a pretty high precision 91, 81, recall 50 is not so great, 98 is good, but I feel like we could just do a little bit better on that. So we test this here on the training data and also the test data. Here we can see we only have 46% recall, which is not a really great model performance. So we need to really do something, I think, to improve the model performance here a little bit. What we can do is we can first check the coefficients and find out which ones are actually the good coefficients that help us to predict attrition and drop then, for example, later on the other one. So what I'm using here is I'm just calling the columns from our training data set, and I am taking the coefficients, and then I'm just going to sort them by their prediction value. So basically here, the higher the value of the coefficient, the higher the importance of the model. You can see here that over time, it's a very important predictor, business travel as well. So employees that probably have to do a lot of overtime are not so happy, so they quit the job. And then you have some others that are not really relevant at all. Once we know that, we have gotten here the coefficient of the logistic regression model. That's not really great for interpretation, so we need to convert them back into by taking their exponential. So that's better to be able to make a to really say something about the model coefficients. So what you can see here, for example, is once we've taken the exponential of the log function, we can see that, for example, over time here, employees that have to do overtime, they're 2.6 times more likely to quit the company than employees who are not doing overtime. Same for business travel. It's like 2 times more likely marital status singles. So singles seem to be more likely to quit than people that are married, maybe also because they have kids and then are a bit more tied to the job. What is always great to look at is the precision recall curve for logistic regression. Remember that this is important because you have a bit of a trade-off between precision and recall. As precision improves, recall decreases at some point. So trying to find here the optimal threshold. We find here that the optimal threshold is 35%. If you use that 35% and then model again, you can see that all of a sudden the performance of the model is really increasing. Here recall is now at 64%, which is much better than what we had before on both the training and the test data set, here 63. So already we improved the model performance tremendously by just setting a different threshold. That was the model building using logistic regression. There's also, of course, the possibility to do k-nearest neighbors. I won't do this now in the video, but if you want me to show you a video on that, just drop me a comment and I'll do that as well, but it will be in the GitHub notebook that is uploaded. So yeah, I hope that was an informative session for you. We looked into how to build a model to predict if an employee is going to quit a company using logistic regression. And we understood a lot about the model performance, looking into accuracy, precision, and recall score, and then also improve the model performance by setting different thresholds, taking into consideration the trade-off between precision and recall. So I hope this was a great session for you.